So now we're going to find the inverse of a function. So we have f of x equals 2x cubed plus 3. What I've discovered is students are really good at finding an inverse when they're not asked to find an inverse. Like on my test, I put a question, find an inverse, and students get halfway there and then they get stuck. And then another question, I ask them to do compositions to prove to me that this something is an inverse. And they do it perfectly without compositions, they just do the inverse. They do it like I wanted them to do before. So inverse isn't really the problem. There's something in the process that people just get stuck, and I think they get stuck as to which variable to solve for. Sometimes there's multiple x's, multiple y's, and they're just not sure what to do. So the first thing we need to do, we need to make sure we have an x and a y. You don't want to do an inverse without x and a y. So f of x, that is a glorified way of saying y. So I just write that over my f of x. That is my y. First thing you're going to do for inverses. Change the x and the y's. If there's more than one x, all of them are going to become y's. If there's more than one y, they're all going to become x's. All the x's become y's, all the y's become x's. So our y is going to become an x. Our x is going to become a y. And that's the only thing that's changing. Change the x into a y, change the y's into an x. Okay? Your next step. Solve for y. We want y alone. Minus 3, minus 3. We want y alone. Divide by 2, divide by 2. We want y alone. Cube root. That's how you get your inverse. Now the problem here is if I just say y equals the cubed root of x minus 3 divided by 2, what does it mean? I don't want it. Just y equals, is that the original? Is that the new? Is that the inverse? Is that a completely different function? Is that g of x? Is that h of x? How do I know what that is? So what we want to make sure we do at the very end is you're going to turn the y back into f inverse of x. Back into f of x, but that negative 1 exponent is going to say inverse. F inverse of x. That tells us what it is. At your job, you do your job, but you've got to make sure it's done in a way that someone else can tell what it is. I tell my students the best notes you will ever write are on the day when one of your friends is absent and says, hey, can you take notes for me? Because then you're taking notes so that someone else can read them. If you take notes so that someone else can read them, then when you get home, you'll be able to read them. You don't actually have to share them with anyone. Take notes in that way. This is so that someone else can come back and go, oh, that's your inverse. Okay, yeah, I just thought it was random y. And then that replaces your y. Depending on where you're at in the semester, it may have you rationalize that. Depending on what course you're in, what you're doing, how your teacher wants it done. But for inverses, the first thing is switch the x's and the y's. The reason I chose this for an example is because a lot of people get stuck on this cube. This is where they're going to get stuck and they're going to go, ooh, and they actually end up solving for x instead of y. And then they go back a step. So I wanted to show y'all one with the exponent so that y'all could make sure you knew how to get rid of it. You could see that so that when you get to a test, if it has an exponent, you can get rid of it nice and easily. You don't end up solving for the wrong variable. A lot of my students ended up solving back for x And then they would answer this step. And I'm like, that's okay, you knew step 1, but did you know step 2 or step 3? And so they didn't get most of their credit. So, okay? Change the x's and y's, solve for y. And last, put f inverse of x back, just in place of the y. Okay? So nothing overly fancy, just the process.